do. Okay, so how does induction work? This is like the short version. Okay, if you haven't seen it before, it might be interesting to look up. But the way I think about induction is very simple. It's like what they used to do with all the dominoes. You see those big domino things, right? And you knock over a domino, and it knocks over the next one. It knocks over the next one. Then it knocks over. A whole chain of dominoes. The dominoes for us are the natural numbers. And so induction has two parts. We need to say that two things happen. If two things happen, then we know that all the dominoes fall over. The first thing is you have to knock over the first one. If you don't knock over one to start, you're not going to get anywhere. That part is called the base case or the base step. The second part is you have to affirm what is an implication. You have to say, if a domino falls over, then it must also knock over the next one. Because if you space them too far apart, this one falls over, it doesn't knock this one down, then you stop. You've only knocked down those first ones. So your two parts are the base case or the base step, and the second step which says if you knock one over, then it must also knock over the other one. In terms of natural numbers, what it says is if I can show that some statement is true for some initial natural number, and I can show every time it's true for some natural number, it is also true for the next one. It knocks over the next domino. Then I will know it's true for all natural numbers, true for all the dominoes. So, to show for all natural numbers n, that the number of subsets of a set with n elements is 2 to the n. So that's stated as sort of an induction type thing. We have our base step, or our base case, whatever you want to do. We can say, okay, let's make sure the first domino gets knocked over. N equals 1. Okay, so what n equals 1? What's the question I'm asking?
If the number of elements equals 1.
How many subsets can you make out of a one-element subset, right? Then what is the number of subsets of a set with one element? And what are we trying to show that is? 2 to the 1. We need to show that it's 2 to the first, or 2. Is that true?
Yeah, because for one thing, it could either be in the
set or not. If you have a set with one element, A, doesn't matter what the elements are, the subsets are what?
The whole set.
Subsets are the set itself and the empty set. Those are the only possible subsets. We can actually list them, because now we have an actual number, 1. That's our base case. We just knocked over the first domino. So we know that they're starting to fall down. Okay, now we have to show that every time a domino falls over, it knocks over the next one. In other words, we need to do what's called the induction step. Induction step, which says if the statement is true for k, then it is true for k plus 1. It's for the next one. If the statement is true for k, then it's true for k plus 1. Okay. So what does it mean? This is what we're allowed to assume. The statement is true for k. We're allowed to assume this. In fact, this is called the induction hypothesis. Okay? I'm not assuming that you know induction, but I'm just showing this, you should learn induction at some point. Induction hypothesis. Okay? And in this particular case, the induction hypothesis says is we are allowed to assume that a set with k elements has 2 to the k subsets. That's what we're allowed to assume. What we need to show is we need to show that it's true for k plus 1. We need to show that a set with k plus 1 elements has
2 to the k plus 1 subsets.
2 to the k plus 1 subsets. Okay, so that's what we're doing. Okay to erase this up here? All right, so that's what we're trying to show. We're trying to show that if the kth domino falls over, it knocks over the k plus first one. And we're allowed to assume that the kth domino fell over. Okay, so we start with, right, you know, a set with k plus 1 elements. And we need to show that that set has 2 to the k plus 1 subsets. Okay? So start with a set of k plus 1 elements. So suppose I have k plus 1 elements, right? Okay, take k of those elements. What can you tell me about those k elements? Yeah. Somewhere I better use this induction hypothesis. Okay, take k of those elements. They have 2 to the k subsets. That's by my induction hypothesis. Right? They have 2 to the k subsets by the induction hypothesis. Now what?
You have one more element.
We have one more element.
And there are 2 options for that element.
And there are 2 options. In fact, it's just pretty much, this is kind of an inductive argument here, really. We didn't phrase it inductively, but it's kind of an inductive argument, right? Really we say, okay, now, for the last element, it can be added to each subset or left out, i.e., 2 choices. Now, with a little bit of thought, I'm not going to write down all these things, but you think about it. Okay, so if you're talking about all the subsets of a set with 2 to the k plus 1 elements, either it includes that last element, which means it includes that last element, and then the rest of the elements are some subset of the k elements, which we've already counted, or it doesn't include that last element, in which case it's one of those 2 to the k subsets that we've already counted. Okay, so there are 2 times 2 to the k, because there's 2 choices, 2 times 2 to the k subsets, which equals 2 to the k plus 1. Okay with that? So you can use induction here, and when you see an argument of this type, you want to start thinking about induction. It's a useful technique to actually prove it. Questions? You look happy. You should be happy. Induction is amazing. I mean, where else are you going to prove infinitely many statements in just like a few minutes? Okay? You're not. You know, a lot of times, in political science, they spend an infinite amount of time attempting to solve one thing, and they don't even succeed. We prove infinitely many things in just a few minutes. It's pretty powerful.
This is kind of a tangent, but in class